Now let's talk about percentages and really their relations on eventually parts per million, parts per billion, and what those terms mean. So we've sure you guys have this engraved right now. So you punch 1/4 in your calculator, you get 0.25. Multiply that by 100%, you get 25%. So let's just say you have 25%, and let's just say you want to find what is 25% of something. Um, so you have, let's just say the number, I don't know, 29. What is 25% of this? Well, there's two things I can do. I can either multiply this by 1/4, punch that in the calculator, 7.25. Or I can do, 25 times 0.25 and go straight from there. Get 7.25. Because you're multiplying by the same thing. 1/4 is the same thing as 0.25. And anytime you want to find a percentage of something, you're just multiplying by that number. So let's just say 30% of so 30% of some original number, let's call it A, is 57. So what does that mean? So essentially what you did is you could have done different things. So 30% is 3/10 or 0.3. Well, I guess we'll do it both ways so everybody can really see what's going on. So you had some number, right? So it was A. You multiplied it by 0.3 and you got 57. Okay? Now what do you do from here? Well, I have to isolate A by itself. So what I want essentially to be A is equal to something. And then I can convert that to a number or whatever. So this is what I want. I want A by itself. Now when you have an equal sign, you hear the general expression, what you do to one's left side, you do to the right side. And essentially that's because if you really think about what equals really means, if you had 2 equals 2, okay? If I multiply the right side by 3, so I didn't multiply it by the left side, so I would get 2 equals, the right side 2 times 6. Well, we know that's not right. 2 does not equal 6. That can't be right. So what you do to one side, you do to the other. So you multiply both sides by 3 to get 6 is equal to 6. You just want to keep the equality. This is the equality. Now, when you have addition and subtraction, I don't know if you guys generally know this, but that's when things get different. Like if you had, you know, what is it, like 10 minus 7 is equal to 3. Or, sorry, 10 minus, some number, A, is equal to 3. Well, now we want to isolate the same thing, A by itself. So, um, what you do to one side, you do to the other. So, let's just add A to the left side. So, 10 minus A plus A. And then, you do the same thing to the other side. Plus A. So, minus A plus A is just essentially 0. So, it's like if you said -2 plus 2, which is the same as 2 minus 2. That's essentially 0. They just cancel themselves out. So then now you have 10 is equal to 3 plus A. Now I want A by itself, okay? So what am I going to do? I'm going to subtract both left and right side by 3. So now you'll get 10 minus 3 is equal to A. You took 3 away from this side, so that cancels the 3 you already have. Then you take 3 from the left side, that leaves A is equal to 7. Whether it was like 7 equals A or A equals 7, they're the same thing. As long as you have this equality, it doesn't really matter what order you do. So, adding and subtracting, do left side, do the right side, multiplying, do left side, right side. So let's just say we want to do this a different way. You do A times, I want a different way of showing 0.3. So A times 3/10. Or, yeah, you can do it this way too. is equal to 57. Now, whatever you do to the left side, you do to the right side. So let's just deal with the top first. You know what? I'll start us with a new page. Hopefully that'll make it easier. So what do we have? A times 0.3 is 57, and A times 3 over 10 is 57. And you want to find A. So you're saying 30% of something is 57. 30% of something, which is A, that's the something you started with, is 57. So what are we going to do? How are we going to get A by itself? So you divide, want to get rid of that 0.3. So, to get rid of something that's positive, let's just say you're adding, you do the negative. If you have something negative, you do the positive. If you have multiplication, well, you divide by it. Because let's just say you divided what if we divide both sides by 0.3? Okay, so you have A times 0.3 divided by 0.3, 57 over 0.3. Well, we know that this left side is the same as this. A times 0.3 over 0.3. And this is just 1. It's like having 5 over 5. It's just 1. So now A is 57 over 0.3. Punch down your calculator. Get 190. Now this way of doing it. So you can see right here, what are we going to do? Well, we want to get rid of the 3 first. And then we want to get rid of the 10. So A times 3. Or you can get rid of the 10 first, get rid of 3. Doesn't even matter. So let's just get rid of the 10 first. So you multiply both sides by 10. 3 over 10. This is just 1. 10 over 10. So you have A times 3 is 570. Now we'll divide by 3. So that'll cancel these. And you'll give me 570 over 3. Same thing, 190. Now if you want to skip this whole step, if you just see A times 3 over 10 is 557. And you see that, hey, if I just multiply the left side by 10 over 3, so you multiply the left side by 10 over 3, multiply the right side by 10 over 3. Essentially, 3 gets rid of 3, 10 gets rid of 10, because they're divisible by each other. So you're just left with A is equal to 57 times 10 over 3. So 570 over 3, which again gives you the same thing, 190. And this whole purpose was just to, kind of, the wording of the question was, dealing with percentages, but look what it dealt with. It dealt with everything we've learned so far, multiplying, doing fractions, and all that. So, what did we want? We said that 30% of something, of A, let's call it A, was 57. So once you know how to, write this as an equation, then it's just a matter of isolating what you want. So you just wanted A. So 30%, now we know that 30% of 190 is 57. And the way you can see that is, let's try it out. 190 times 0.3, or times 3 over 10, whatever you want to do, you get 57. And that's how you check that you have it right.